Hi, Denise and Paz. How are you guys doing?
I'm good, sir. You?
Giving thanks. A little bit under the weather-ish, but it's nothing to prevent me from coming out. I'm just wondering. It's now 7:15, 7:17 actually, and I'm just wondering if it is because it's a holiday why people not coming out, but one or two they say them going to come in. I know Alexis was here earlier, and then she drop off.
Yeah, I think it's probably because of the holiday, because even the other class that we had early on, um, majority of the class wasn't there. So
No, but the teacher turned up still.
yeah, she turned up and she spoke to the persons who were in class. So
Nice. I think that's what I will be doing. I don't think the truth is I don't think I'm going to be here for beyond 8 o'clock, as I did ask, for persons to just go ahead and just read through so we can just have a conversation. I'm trying to see. Well, I'm not finished the syllabus. I'm not worried about that, but based on the conversations we were having the last time around. So I know your internet is very unstable. Paz, I don't want to ask you to do anything. Benicio, I see that you're talking via the chat and not microphone. Is it that your mic not working?
My mic is working.
Okay. Are you able to share project a document for me?
No, so I'm currently using my phone.
Or are you using a phone? All right. If you're not here, and I know, Paz, I know you'll be willing, but you and your internet, you look like you live behind Jesus.
sir, most of the times, it's my work internet that actually gives the issue.
Oh,
Yeah.
okay. All right. I'll wait off another 5 minutes and see if people will come in. If not, because you are already here, I'll just maybe have a conversation with you for about a half an hour, and then we'll just call it a night. All right?
All right, sir, no problem.
Cool. All right. I guess it's just us three. Um, and let me see what can happen here. hmm I'm not going to push it this year because really it's a holiday. I was only trying to be very hopeful that it would happen. Hence my asking the question. When I asked. Can you see the screen?
Yes, sir.
Yes, sir.
Hold on. Let me see if. All right. So I'll just go through this one. The 23 pages of this one, and then we just call it a day. Because really and truly, I'm not 100. I wouldn't mind using the time myself to just kind of relax, but recognizing that there is work to be done, I say, let me just push it. So let us see if we can do this in up to 8 o'clock. So it says in geology, a fault is a planar fracture, and we spoke about this the last time around. What a fracture is, versus a fault, right? And so it's a planar fracture or discontinuity in a volume of rock across which there has been significant displacement along the fractures as a result of Earth's movement. And of course, can you see the fault line right here, all of you?
Yes, sir.
The man.
Yes, sir. I can see it.
You can see the fault line. Good. Nice. So this piece has been pushed up. This piece has been pushed down. Can you see that?
It's like a slant.
Very good. Excellent. 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 All right. All right. So there are different types of faults, and this course does not take us into all the types. So I'll just skip through the ones that we will be interested in, but it makes a good read. You all have this in your in your WhatsApp group. So it says fault related joints. Joints also formed adjacent to brittle faults, and movement along faults usually produce a series of systematic fractures. Most joints formed by extensional fracturing of rocks in the upper few kilometers of the Earth's crust. The limiting depth formation of extension fractures should be ductile brittle transition. Can you see any fault lines in this thing here?
In the center.
Sorry. Right here?
Yeah.
Very good. So that's where the fault line is. Right? So sometimes you have to look carefully because at a quick glance, you will not necessarily see the fault line right here, but there's a fault line right here. Pretty easy for you to pick up the faults. Right? What is important for me now for you guys to do is to be able to identify the different types of faults. Right? But this here is where the fault is. All right, good. Understanding faults is useful in design for long-term stability of dams, bridges, buildings, and power plants. The study of faults help understand mountain buildings. Faults may be hundreds of meters or a few centimeters in length. Their outcrops may have a knife-sharp edge or fault shear zone, right? So it's important for us to be able to identify these faults. Now, and the different types of faults. So this is where I want the conversation to go. It's good when you can identify the fault, but you need to be able to tell me which is a footwall, which is a hanging wall, where is a fault plane, right? The dip of the fault, strike. So when you hear me talk about things like dip and strike and footwall and hanging wall and fault plane. So these are the parts of the fault. A fault plane is a surface.
So, quick question. So you're saying that all faults basically have all of these
Yes. Characteristics. Yeah.
Yeah.
So it's for you to be able to it's for you to be able to tell me where they are and to describe them. All right.
Okay.
So the fault plane, the surface that the movement has taken place within the fault. On this surface, the dip and strike of the fault is measured. So the fault plane is here. So we need to get the dip and the strike. So look at what is happening. This here gives us the dip. This gives us the dip of the fault. All right. And this is a fault strike. So when you go out into the field, you will have your your equipment to measure the dip and the strike, because it gives us an idea as where the hanging wall is, where the fault plane is, where the footwall is, and it tells us a whole lot about geologically about what is happening. Because if the dip and strike favor the dip and strike in another outcrop hundreds meters away, you can see that clearly this fault is a fault that runs from here to. You remember I said to you some time ago that you have some fault lines that run hundreds of kilometers in length.
Yes, sir.
Yeah, man. The dip and strike of those fault lines will be pretty similar, right? So think of it this way. Think of a line. And we're using mathematics now to justify what is happening here. Think of a line. And the line that you're thinking of, Paz, what area you know?
First year.
Area.
Oh, Kingston.
All right. So Paz is in Kingston. Anybody in St. Catherine? And then so what area in?
Sir, St. Andrew.
In St. Andrew. All right. So okay, that's good enough. So there is a fault line from where you are, Paz, in Kingston, to where Denise says in St. Andrew. All right. And I want you to listen to me carefully now. Don't know your mathematical ability, but if I catch you for pre-calculus, I think I'll find out. If I take the gradient of the line, the same line that runs through Paz and Denicia, if I take the gradient of that line closer to Paz, and I take the gradient of the line closer to Denicia, it should give me the same gradient because it's the same line. And if I take the gradient in the middle of it, halfway from Paz and halfway from Denicia, I should get the same gradient. Why, sir? Because it's the same line. So the dip and the strike should be the same wherever you go. So this is why we're saying, if we really want to connect the fault line, we'll take the dip one place, the dip and the strike one place, and we'll go up top, and we say something, we take the dip and strike, and this is how we're going to be measuring the dip and strike across, if we can trace the fault line. Now, once we can trace the fault line, and the dip and the strike comes out to be the same thing, we can say that this fault runs from here so, right back to over there so. So it runs from Kingston right back to St. Andrew, because it looks alike. The mineralogy around the fault is pretty much the same. and we're following the trajectory. Remember, you'll have to cut through the surface of the earth in order for you to see this stuff, You remember, the earth is going to be, it's covered with topography. We call it now. Houses are being built on top of the stuff, so you're not going to see that thing. But you have one exposure of the fault somewhere out here, so where the man them cut through the lithosphere to form the road on one side, right? And then that fault line runs from St. Anne go all the way through Clarendon. And Clarendon them cut through piece of the road again to make another highway. But you're seeing a fault there, and you say, but hold on. This fault looks like the same one we just map, St. Anne. Hold on there. But the footwall is in the same direction as the one over there. And I'm saying, no, man, let us take the dip on the strike of it. And when you take the dip on the strike, you get in the valley, you say, why? Are the same fault that runs right through. And then now, you are able to do some mapping geologically, what is happening. And this is how, and as I said before again, and I'm going to forever say it, and this is how we are able to connect the dots. The dots are out there to be connected, and this is how we're going to be connecting the dots, right? So that's a fault plane. That's a fault plane. The plane is where you're going to be having that movement, all right? And if you look at the mathematically, if you think about what a plane is, that's exactly what it is. The plane is exactly here as we would have it in mathematics. Now, the hanging wall, that's a rock mass resting on the fault plane. Can you see that?
Yes, sir. Looking at the diagram.
Yes, ma'am. So look at the diagram as I go along. So the hanging wall is that mass resting on the fault plane. Right? So it's as if it is hanging on it. The footwall is the mass beneath the fault plane. It's a mass beneath the fault plane. And the hanging wall is a mass resting on the fault plane. Right? So one is resting on the fault plane, which is a hanging wall, and the footwall is just beneath the fault plane. So once you can identify the fault plane, that means the footwall is going to be beneath that one. So you just need to be able to differentiate and distinguish.
So I don't really see the hanging wall still. It looks like the footwall to me.
See the hanging wall there?
Yeah, I see it there now. But in terms of like how it looks in relation to the footwall block,
all right.
The other picture, it looks the same.
Okay, all right. So let me explain something now. Boy, I say one time, I see mango in a tree. I'm one impress girl. So me climb the east Indian to pick big mango for go pick and go give girl, because me want impress girl. And me want me the kind of win because girl turn wife. So when me can climb any tree now. Give me any coconut tree. Give me any tree for climb. Me can climb it. You know what my problem is?
To stay on.
So come down. So me can climb any tree, but when me for come down after the tree is a problem. Because it's when me look down and me see ground, and me say, oh hell no. Because all me see is just me dropping off the tree. But I can climb the tree. Once I climb tunnel vision, I am going up, I am going to go up to the tree. So I remember going up to this tree. Big extended tree now. And I'm going to tell you, it's about 12 feet up before you have the first limb. But hug up that man and climb that and reach the first limb and step up and jump on and jump up and reach and walk out and grab mango, throw mango ground, and people catch mango and thing. Them say, all right, now take time and come over support. So me reach the 12 feet and say, boy, me if you come back down, me couldn't make it. So you know the eye do? The eye swing off or something. And when I swing off, me just say, all right, I jump, me go jump and jump. Kind of did hurt my back still, but jump. What's the moral of the story? It's when I climb on the tree pads, and me a swing off. Don't hang me a hang off on the tree. Talk truth.
Yes, sir.
All right. So look at the hanging wall. The hanging wall look like it just piece on the fall plane, and I hang off of it. Like our teacher they hang off of the tree. Talk truth.
Yes, sir.
Yeah, man. Hey, studying is real life, you know. I real life, something I talk about, you know. So you just think of you holding on something for dear life, right? But me go tell you the truth, you know. It's all if me they look down at me, see two alligator down there, two bad dog. You know, so me nah let go. Me say me nah let go, cause me know if me let go, them go bite me up. You understand? So me go find some strength for go up back in that tree, for go sit down in there until then the dog they move. Think about it. I'm hanging. So if you look at the right side of the drawing here, don't it look like the hanging wall? Don't it look like a hang off or something?
Yes, sir.
Yeah, man. So that's what the hanging wall is. Hope you catch that. All right, the slip. The slip describes a movement parallel to the fall plane, right? The slip describes a movement parallel to the fall plane. The dip slip describes the up and down movement parallel to the dip direction of the fault. Right there, so. And the strike slip applies where movement is parallel to the strike of the fall plane. Right here, so. Fall strike. So the dip is a dip direction of the fault, and the strike is the strike of the fall plane. So you often hear people talk about the dip and the strike. The dip is a dip of the fall, the strike is in the fall plane. All right? Good. And then you have an oblique slip. Now the oblique slip is a combination of slip slide and dip slip. All right? And then of course you have the net slip, but you're not required to know this part.
So, sir, the oblique slip would have been like in the previous picture.
Something like that, yeah. Where it's a combination of both dip and strike.
Okay.
All right, now. So remember now, we have the hanging wall is when they sit now hold off on something. All right. So the hanging wall, this is, of course, you can see the fault, right?
Yes, sir.
All right. And so the hanging wall here, think of it that this piece a drop off, and it a hold on the limb like a teacher did with the East India mango tree. Don't you can agree that this is a hanging wall?
Yes, sir. This is a better picture.
Okay, thanks.
Yeah.
What is this piece here?
The dip.
So the fall plane.
Oh, the fall. Yeah, the fall plane.
Right,
yeah.
the fall plane, right. And the dip now is going to be this piece here, so right here, so the dip is going to be from here to here, and then the strike is going to be along right here, so of the fall plane. You follow me? So the so the hanging wall, and you know what's happening there? The hanging wall is going down. You see it there? You have an arrow, and the down piece here is going down because you know you hang on for dear life, you know. Aye. Tom and Jerry is a perfect example. You know, sometimes they say Tom hang up on something and then he might go down and see one alligator company to start run. Of course, those are cartoon. It has to be cartoon because real life don't work in ways. Just think of it. Hanging while you're hanging. That's exactly what is happening. So you're going down. The footwall is this piece that is here. Let me go back and show you something here. See the footwall is as if it's going up. The hanging wall, this piece is going down. This is a piece of the arrow that is coming down, and this arrow is a direction of relative movement. So the movement is this way. So when you are coming down, that's a hanging wall. So if you can identify the piece that is coming down, that is known as a hanging wall. And of course, the other one is going to be the footwall. And the displacement here so will expose the fault plane. And the fault dip is this way, and the strike is this way. All right? So yes. So it says this side drops down relative to the other side. So because it dropped down, it is a hanging wall. See it here, so? It got down. It's a hanging wall. Question. Let me hear your questions. What questions you have of me?
So this one would be the oblique slip.
I'll show you what the oblique slip is. Remember the oblique slip is I'll show you what the oblique slip is. Right? That's a combination of both dip and strike. What I'm trying to do is to take it in stages for you. So it is that you can be able to identify the footwall, the hanging wall, the fault plane, the strike plane, the dip of the thing. So it's for us to identify sections of the fault, right? So I will go through all of those, and of course, well, I don't need to go through that. But we'll get there. Let me move on to second. All right. So it's the fault plane. Can I agree that it's the fault plane? Sorry, the fault line.
Sir.
Which side is this piece over here?
The hanging wall.
How you know that?
Because it's hanging. It's hanging.
It's going down.
Yeah.
All right. Don't say hanging, but it's going down. All right. So this is a hanging wall. And then the footwall is going to be, sorry.
The one going up.
Right. The footwall is the one going up, right. And then of course we can have the fault plane right in here, so don't.
Yes, sir.
Right. What else can we
the fault dip.
All right, so I did something that, oh, come on, Sir Shant. Okay. Right, so the dip is going to be, the dip is going to be this way. You take the dip this way.
So it can be on either side?
Huh?
The dip angle, can it be on either side?
It can take it on either side. Yeah.
Okay.
See what you're using a protractor, your compass, your protractor. You have a circle. When you're using a protractor, you can read the protractor from both sides, you know. Right?
Yes.
So, yeah, so you can actually read from both sides. So the dip is going to be here, and this is going to be your strike plane. Right? Your fault plane is here. This is going to be your footwall, your hanging wall. So you should be able to identify that. Now the footwall is that piece that goes up. The hanging wall is a piece where hang on for life. But if they ask you to describe a hanging wall, don't say that because it hangs. Because you can't use the same word for do this stuff, eh? So that's what that one is pictorially. So Anderson 1942 defined 3 types of faults: normal fault, truss fault, wrench fault, oblique fault, right? So we'll look at some of those. The oblique you will need to know, but on the truss, normal, yeah, we'll look at some of those also. All right, now, so all right. So here now is where we have some types of sorry, hold on. My phone. All right. So we have a shear stress that is taking place right here. All right. Now, one of the things that I will say to you is, remember how faults and fractures are formed. it is because of the compression of plate tectonics, right? So you remember you have the compressional stress, one moving from one side, the other moving to the other side. So it is that compression that is is taking place on either side of the structure that generates some level of stress. And here it is formed the symbol used on a map to indicate a thrust fault. So whenever you see these arrows going right here, so that is going to be your thrust fault. And see your fault line here, right? This is going to be your hanging wall.
Yes, sir.
Right. And your foot wall. Now, look at what happens here. You can have it's so for example, now we're talking about lakes again. Oh, come on, Mr. Sean, why you keep doing this? All right, so think of the compression. The compression, you're going to have compression taking place from either side, and you're going to have that sort of stress that is formed between, and that's what causes the fault. So this is a thrust fault. Is a thrust fault? Is a thrust? Yeah, thrust fault. Right. I don't think the thrust fault is on your syllabus. Let me just check something here because I don't want to be. Can you see the screen?
Yes, sir.
All right, so we're talking about plate tectonics. Can you see number 4?
Yeah. Yes, sir.
Right, so we're talking about plate tectonics. So look at that. Folding fault in dip strike oblique. So the thrust fault is not something that we need to be looking at. I mean, we're not getting into the nitty-gritty of those. One of them though, when I get there talking about it. So it's just related to the strike oblique that we need to be looking at. All right, let me see if I can get back to. All right. All right, so this is a thrust. Let me not spend more time on that. Oblique slip fault. Okay. All right, so there's something with the oblique that I need to show you. It is showing right here, but I don't like how this picture looks. So the dip strike fault, of course, so the hanging wall right here. So this is a normal fault. So you have the hanging wall right here, and you have your foot wall on this side. The truss fault here is like a reverse fault. So you see the truss fault here, this one moves downwards, this one goes upward, but it's still the hanging block. This is still the foot wall block, right? So this is a truss fault, all right? And then of course again you have this the shear slip right here. It moves from side to side. It's not vertical, but it's almost horizontal. So you have a right lateral and you have a left lateral, right? So the right lateral, left lateral, we'll talk about the dextral and the sinistral. And the dextral and the sinistral now will give you definitions of the oblique faults. And we'll get to that. I think I have a nicer picture to show you about the strike slip fault, the one that is lateral, So you have a right lateral and a left lateral. You need to know the difference between the right lateral and the left lateral. So if you look at the fault right here, you can see this block coming. You can see the side here of this block. So this is why it's called the right lateral. And this one here, you're seeing this plane right here. So, which is why that is called the left lateral. Now the right lateral is called the dextral fault, and the left lateral is called the sinistral fault. And so the oblique slip faults, now we talk about the sinistral normal and the sinistral reverse, right? So you have sinistral and you have the dextral, right? I have a nicer pick, as I said before, that I don't know why I decided that I want to meet it, you know, because now that I'm talking a lot, it kind of making me feel worse. Like I said before, you have the stuff that you can go and look at on your own. So they say the normal fault, the hanging wall here has moved down relative to the foot wall. The hanging wall has moved down relative to the foot wall. So tell me now, let us look at this picture here. Sorry, let me see if I can. No, I can't, so let me do that. Which you think is the, okay, can you identify the fault?
Yes, sir.
Do you agree that right here?
That's it. Yes, sir.
What about here? Is this another fault line here?
It looks so.
Okay.
What's that in the center though, sir?
What here?
Horizontally.
Here?
Between the two faults that we just show.
Mm-hmm.
Yeah, right where the horizontal, right in between the two faults that we just.
When you say what is
there's a horizontal line there as well.
Right here, so?
No, lower.
Right
at the base of the two faults. Yeah, that line.
Yeah. This here?
Yeah.
No man, it's just a layering of the fault.
Okay.
It's a layering because if you look at that, you recognize it is also belonging to over here. I seen that.
Seen that.
What do you think has fallen? Let us look at this side of the fault line. Is this a piece that is hanging down, or is this a piece of hanging down? Where's the foot wall? Where's the hanging wall?
All right. So the foot wall is the one on the left.
Very good.
The diagram.
Very good. I'm so proud of you. Very good. And the hanging wall is going to be here, don't?
Yes, sir.
All right. Now, somebody again says, sir, how you know that? When you look at the fault, you see this piece here that I think this is the piece that Paz was talking about. You see this piece right here. Can you see this? Can you see this cursor?
Yes, sir.
You see this piece right here, so? It connects to this piece up here, so. Can you see that?
Yes, sir.
And this piece down here, so. Also connects to this piece right here. So this piece in the middle here, like that little VU sort of looking here, this piece is a piece that is hanging. It falls. It's going down. So that's what that piece is. That piece is a hanging wall. And over here is going to be the foot wall. Let me ask you a question. Is this a fault line?
So it looks like that to me. It looks like a second fault line.
I want to hear from the rest of you.
Sorry, though.
It does? I would call it a fracture. You know why?
Why, sir?
Because I'm not seeing any displacement of the stuff. This here is in the same line. This other layer is in the same line. This other layer down here is in the same line.
Yes, sir. Like for the one over here on our left. you see the deep or something.
Right.
And over here, so like everything in line.
It's just everything is in line right here, so don't it? You don't think
Yeah.
so? Yeah, man.
Yeah.
As it don't feed. Everything is in line right here, so this piece in the middle here come across here, so it's in one line. This is in one line here, but over here, so now you can see that there's some movement, right?
Yes, I see it. I see it. I
Okay.
see it. Yeah.
Right. So I will call this piece here so a fracture, right? Now this fracture, if because they have a fracture, have an area of weakness in the exposure, true or false?
True, sir.
So any little earthquake or any little sudden movement or any compression, say somebody decides say they're gonna build one something and use one tractor and start excavate. You know what's gonna happen? That fracture may end up becoming a fault because it may not have a hanging wall, footwall sort of saga. But as it is just now, it is a fracture for me because I'm not seeing any displacement of anything taking place.
Yes, sir. I see it.
Right. Let us look at this side now. Woo! What is this line?
That one is a fault.
Okay, the fault.
Displacement. Yeah.
All right. Which is the hanging wall? Which is the footwall?
All right. So the footwall is the one on the right, and the hanging wall is the one on the left.
Everybody agrees?
Yes, sir, because the hanging wall is the one going down.
Yes,
On the left.
Where's the hanging wall?
Sir, to me, would I dip on the right?
Talk to me.
On the left for me.
What is it? What is the hanging wall on the left?
Yeah.
Okay, that's what you said earlier, Paz?
Going down.
That's what you said. Originally, you said the hanging wall is on the left. That's what you said originally.
Yeah,
Yes,
part
sir.
on the left and the left.
Oh, okay. Somehow, Paz, I thought you said it right.
Oh, for real?
Yeah, honestly, that's why I hesitated but yes, if you said the hanging wall is on the left and the footwall is on the right, I would agree with you. So that's what you said, right?
Yes, sir.
Okay, and then no, I heard the others agreeing, so that's pretty good. And it says here the hanging wall has moved down relative to the footwall. So yes, so this here is the footwall, the hanging wall rather, and up here is the footwall, and so forth and so on. Very good, very nice. You guys are catching it. So you see, for me to to show you how something like this now in real life, I'll maybe take you into the gorge, and we're going to stand along the side of that very wicked river, to look and to possibly map out and maybe use binoculars and see if we can see some stuff. And because since we can't go over there, and I don't take students on them trip because they may say, "Oh sir, I can't swim, I can go over there." Me gone with you, because you can't tell me, say me tell you, say me go to go over there. But we'll have to take it to different exposure, and sometimes it's kind of limited to get there. So looking at those stuff on pictures like what we are doing here now, should be able to, should you see one of these, you should be able to identify it. So yeah, man. So as a quick recap, we look at the plane fault, the strike slip, the dip slip, the hanging wall, the footwall, and we look at the fault line itself, right? So we know how to identify some of those stuff. All right. So the truss fault, in the truss fault, but I didn't say anything with the truss fault on the thing, right? So I'm not going to look at the truss fault. I didn't say any truss fault. You can read it through in your own little time, but I didn't say anything on the truss fault in the But you see, the thrust fault has, no, that's the oblique fault. All right, so the thrust fault is not what I really want. All right, so the strike slip, this is what is going to be important. Do me a favor, I'm going to ask you to read through this for me, please. Let me just step away for 2 seconds. Just read through this for me and then we'll come back and have a conversation on it here. Cool.
Okay.
Sir?
Yeah, him saying was going to step away for a while, so you should just read what's on the screen, and then when you come back, you discuss it.
Oh.
Anybody found today to be very hot? Hotter than usual?
Yesterday was hot for me. Today wasn't so bad.
No man, trust me man. Today was unbearable. And I say unbearable? Unbearable. All right. So when we look at a strike slip fault, are faults that have movements along strikes. Along strikes. There are 2 types of strike slip faults. You have the right lateral, you have the left lateral. All right. So as I was explaining to you earlier in the diagram before, so this is a lateral movement. So remember now, oh Lord, how do I do this? Remember now, what page is this? 15. When we reach 23, we'll call it a day in class for today. Where were we? No. Come on. Right. So the dip takes place right here. The strike, the fault strike is parallel to the fault plane. So the strike fault is parallel to the fault plane. Can you see that? So see the fault plane right here, so? And the fault strike
Yes, sir.
is parallel to it. All right? So let's just go back to 15 now. So this is a strike plane. Fault strike here. So you have one movement going this way, one movement coming this way. So it's a lateral movement. Lateral means from side to side. Vertical is up and down. All right. So the lateral movement is going to be the strike, the fault strike, and the fault strike is parallel to the fault plane. All right. But my lateral strike, I have my right lateral and I have my left lateral. I have my right lateral and my left lateral. Now, very important. This one is a right lateral. This one is a left lateral. How are you going to be able to identify the right lateral from the left lateral? Now, it says right lateral strike fault, which is a dextral. The dextral is the right and the sinistral is the left, where the side opposite to the observer moves to the right. So see the observer out here, so. You see the observer standing right here, so? And when you look at it, the one you're going to be seeing the right of this piece of the block to you. And the left lateral strike tip is where the opposite side of the observer moves to the left. So you can see the left of this. Are you following what I'm saying?
Yes, sir.
All right. Now,
So
go ahead.
So to in other words, to determine like whether it's right or left, you could think about it like in terms of like the direction that it's going, like
And
downward.
that's exactly what you need to do. So what I thought you were going to say, Paz, is what if, sir, you were over this side? Watch my screen. Watch my hand on the screen. If I was on this side and I'm looking this way and I'm looking this way, you recognize that this is still on my right hand side?
Yes, sir.
Right. And if I look on this way, if I look for the left lateral now, if I look this way, the left one is still on my left hand side. So this will be my left hand side looking this direction, right? From coming this way, right? So yes. So you have the right lateral. The right lateral, remember the right lateral is called the dextral and the left lateral is called the sinistral, right? It says, note that the same sense of movement will also observe from the other side of the fault, which is what it is that I just showed you. All right. So you just need to be able to, for the strike slip fault, you need to know, your syllabus talks about strike slip. So you need to know how to identify the strike slip fault. The sinistral, the dextral, sinistral is going to be the left lateral and the dextral is going to be the right lateral. Do me a favor. Just read through that one more time for me, please. Very important. Read it to yourself one more time. Please. Boy. Okay, that's me. All right, now?
Yes, sir. Finish.
Nice. What about the rest of you? How many of us here now? Still 4? Still 3 of you? All right, no problem. All right. The transform fault. Not looking at that. Oblique fault. I need to look at those. So oblique faults are faults on which two directions of displacement occur. It is a combination of the dip slip motion and the strike slip motion, right? So when you have the dip and strike taking place, is when you have a oblique fault. Therefore, there is a space between the faces of the fault, and on one side is higher vertically than the other. All right, so let's go again. The oblique faults are faults on which two directions of displacement occur. It is a combination of a dip slip motion and a strike slip motion. Right? So you're going to have the dip and the strike taking place together. There is a space between the faces of the fault. There's a space between the faces of the fault. And one side is higher vertically than the other. So there's a space between. So you can have the dip here. So this one here is a dip, and this one here is a strike. So normally, normally, you notice that this is in the, this is my hanging wall. So all that is seen here is just a dip that is going. The hanging wall come down here. The foot wall is going up here. But for the oblique fault, this hanging wall is going to push this way. So you're going to have some displacement of this piece here, this tree falling. You're going to have some displacement going backwards that way. Can you see what I'm talking about?
Yes, sir. So it's going down and
across.
Right.
Yeah. And across, right. Okay. You get me. So this is what I'm saying. So it's going down, but it's also going this way up. Is what I'm saying? So you have two things taking place. So see the strike here. This is a strike which runs parallel to the fault plane. Remember, the strike runs parallel to the fault plane. And the dip now is going to go this way. It's almost perpendicular to the strike here. All right. So you have the oblique fault because you have both dip taking place and you have strike taking place. Normally, if this were just a dip fault, a fault dip or a fault strike, fault dip, this piece here, this tree here will come closer to that until it falls in this line here, and this line falls here, so you won't have a strike. Make sense?
Sir, that one they missed me.
No, what I'm saying to you, had this been a fault dip, this line here, you won't have a displacement from here to here. The displacement will be in line with this fault plane right here and the fault plane right here. So this piece would have come back this way. You follow me?
Yes, sir.
Yeah.
Yes.
Cool. Now, Rift Valley. No, we're going to look at that. Horse fault. No. Not looking at those. Fluid fault, brittle and ductile fault. Not looking at those. Those are not on our stuff, but it makes for good reading, right? So, so those are the. I'm not going any further because my throat has acted upon me again. I really should have taken the day off. I guess this is what the Lord was saying to me, but I just need to do some stuff with you guys. All right. It is not difficult for you to understand. It's not difficult for you to identify. What I'm going to ask you to do, guys, please. I'm giving you half an hour, pretty much, on your holiday. So, me, bright, on your holiday, I'm giving you half an hour. I have the links in the WhatsApp group. Just click on the links and just watch them now, so that when we come to class, now you can say, "Sir, what do they mean by this, so that I can try and give you some explanation as you go on. All right. So just see if you can just get some reading done up. And as soon as this recording becomes available, like I did the last time, I will send it off to you. All right. Fair enough.
Sir. Yes, sir.
Nah, hopefully, take care, guys. All the best.
All right. Yeah.
Mm-hmm.